This is a practice exercise from page 141 in the textbook. In both of these problems, we're using molarity as a conversion factor to allow us to convert between moles, grams, and volume. So if we take a look at the first problem, they're telling us that we're solving for grams, and they're giving us information about a volume and a concentration. So we should know that since the formula for molarity, capital M, is moles over liters, if we have two pieces, if we've got the concentration and we've got the liters, the volume, then we can solve for moles. And we know how to convert grams into moles. We'll need the molar mass to do that. So since we're going to need a molar mass, the first thing I'm going to do is I'm going to calculate the molecular weight of sodium sulfate. And rounded to one decimal place, you should get 142.1 grams per mole. And we know we need that because we're converting to grams, and the only way we can get to grams for moles is using the molar mass. Okay, so since we are trying to solve for moles, I'm going to set up my calculation so that I can use the molarity as a conversion factor. There are a few different ways to set up this problem. As long as your way works and you can explain it, that's fine, but this is how I would solve the problem. First thing I'm going to do is I'm going to think about how many liters 15 milliliters is. So remember that we moved the decimal 3 times, so I'm going to be looking at 0.015 liters. And I know that the concentration of this is such that there are 0.50 moles of sodium sulfate in every 1 liter, because that's what the molarity means. So what that's going to do for me is it's going to cancel out my liters, and it's going to put me in units of moles. The next thing I need to do is cancel out the 1 mole of sodium sulfate with the mass, which we know is 142.1 grams. So that's going to get rid of the moles and leave me in units of grams. Looking at the significant figures, we only get 2 significant figures, so the answer is just going to be 1.1 grams of sodium sulfate. Again, there are a few different ways to set this up, but I like using the molarity as a conversion factor. So in order to do the second problem, again, look at what we're solving for, look at what they're giving us. So this time we're solving for milliliters, and they're still giving us the same molarity, but now they're giving us moles. So in this situation, they've told us the concentration, they've told us the moles, so we are going to be solving for volume, which means I can still use the molarity as a conversion factor, but it's going to look a little different. Something else to point out, since I'm not converting to grams, I will not need the molar mass in this calculation. So I'm starting with my 0.038 moles of Na2SO4. I know that in every 1 liter there are 0.50 moles. And again, this conversion factor, this is just the molarity. So this is what I was using up here as a conversion factor. I'm just using the inverse. I flipped it over because this time I want the moles to cancel out. The last thing I'm going to do is they're specifically asking me for milliliters, so I'm just going to add the conversion since I know that there are 1,000 milliliters in every 1 liter. So that gets rid of my liters, puts me in units of milliliters, which I want. And again, I only have 2 significant figures, so my answer is going to be 76 milliliters of solution. So again, there are a few different ways to solve these problems, but generally an easy way to do this, and something that makes it very similar to the other problems we've solved, is using the molarity as a conversion factor. Please pay attention to if they're asking you to solve for moles, milliliters, or grams, and the only time you need a molar mass is if you're solving for grams.